Hello, geometry, and welcome to lesson 9.4 on parabolas in the coordinate plane. You definitely have some experience with parabolas when you talked about quadratic equations and functions in Algebra 1. So we're actually going to do part of what's called conic sections, which are a piece of analytical geometry. We did circles in 9.3, right? That's an example of a conic section. So now we're going to talk about parabolas. And we're going to use a sort of a different formula today as we go through than maybe what you're used to when I say the word quadratic or parabola. Okay. All right. Okay, so it says explore the graph of a parabola. It says what is the set of points that are equidistant from the graph of the equation y equals -2 and the point 0, 2. So when we talk about the set of points that are equidistant, right, the math word for that is a locus. So a circle is a locus of points because it contains all the points equidistant from the center. So we're going to do the same thing here using this line and this point. So we take a look here, right? So here's the line y equals -2, and here's this point 0, 2. So we're looking for all points that are equidistant. Well, first of all, I know 0, 0 is going to be equidistant from those 2 points. 0, 0 is 2 down from this point and 2 up from this line, right? So there's a point. Next, if I go up to the level of this point and I go over to the right, I can go over 4. Because this point 2 is 4 above the line, all right? So any point on this line here, horizontal with this point, is going to be equidistant, or not, is going to be 4 away from this line down here. So if I put a point there, right, it would now be 4 this way and 4 that way. So again, just to show you, right, so this is 2 and 2. This is 4 and 4. All right. Now the last one is going to be a point that is 10 above the 10 above this line, but coming from this level of 8. The reason I know this is because I have Pythagorean theorem in my head right now, right? But if I pick a point that is 10 above this this line, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? If I go right there. Now, I want to know, right, that this is 10 to that line, but now I need to find its distance, and I'll do it in purple, to this point. Right, what is that? Well, to do that, I'm going to create a right triangle. Right? And now, this horizontal distance is 8. This vertical distance on this purple triangle is 1, 2, 3, 4, 5, 6. So then to find this distance, call it D, I'm going to do 8 squared plus 6 squared under a square root. And I know that that is 100, and the square root of 100 is 10. So this is also 10. And that point is also equidistant. And I can mirror these points on the other side too, right? So instead of going to the right 4, go to the left 4. And then where the 8 is, go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is going to be my parabola. I'll connect the red dots as best I can with a U-shaped curve, right? The other side's a little harder, sorry. Oh, yeah, it's terrible. Let me just try to do it backwards. What if I do it down like this? There we go. Close enough, right? Okay, and there's our parabola, right? So again, we wanted to define this parabola. So for all x and y's, right? Any generic x and y, let's just put an xy right here. For all generic x, y's, they are equidistant, right, from that point to the point 0, 2. So this distance here, call it D1. I'm sorry, that's the second distance. That distance is the same as this distance to this horizontal line. Call that D1. So D1 is going to equal D2. And that is how you get a parabola, right? Now again, understand that this distance is perpendicular, so it's a vertical distance. This one is more diagonal, so you'd have to use the distance formula to find it. So now, again, this parabola that we get, is there another way? Is there a better way to actually find the equation so we can graph it without having to like guess and check? Because really at this point, because I know numbers and stuff, I knew that I could go up 10 because this is over 8 and up 6. And I knew the square root of that was going to be 10. But again, how else can we do this? Well, there is a formula. So let's take a look at the next slide. Okay, so what is the equation of the parabola? So again, a parabola is a set of all points in a plane that are the same distance, equidistant from a fixed point F called the focus. So this point F is called the focus, all right? And this line D called the directrix. So this horizontal line is called the directrix. So again, these two distances, this distance 1 must be the same as this distance 2, right? And again, every point of the parabola is equidistant from F and line D. So to do this, right, we're going to use the distance formula. So to remind you, distance equals parentheses x2 minus x1 squared plus y2 minus y1, sorry. Plus y2 minus y1 squared, all under a square root. So I will start the problem here, and then we'll go to the next slide, I think, where I have more space, right? So we want to show that distance 1 is equal to distance 2. On this picture, that would be P to A is equal to P to F, right? PA, PF. So to find P to A, we have to use P's coordinates and A's coordinates. I will start with P's coordinates. So we'll do x minus x squared plus, and we'll do y minus negative p squared. And that's all inside of a square root. So that's PA. And then for PF, so equals, and then PF, let's use P and F's coordinates. I'll do P's coordinates first. So x minus 0 squared plus, and then we'll do y minus p squared. All inside this square root. Now, the one thing I did not mention as I fill this formula out is what P is, right? So if you notice here, this vertex is at 0, 0, right? So the focus is P up from the vertex, and the directrix is P down from the vertex. So that is always true, that the focus and the directrix are equidistant from the vertex. So keep that in mind as we go through this too. So this P is going to be a mystery number that we're going to see in a formula. All right, so I'm going to pause this. I'm going to copy this on the next slide, and then we're going to simplify it to get the formula. Okay, so next what I'm going to do is I'm going to square both sides to get rid of the square roots. So that's going to cancel, that's going to cancel. What's going to happen here is x minus x is 0, so that goes away. This minus minus becomes plus. So this side is just y plus p in parentheses squared. Okay, and that's going to equal over here, right? X minus 0 squared is just x squared plus y minus p in parentheses squared. And now we're going to distribute this out. So remember, right, this y plus p squared, there is a nice fancy way to distribute it, right? So it's going to be y plus p times y plus p. It's the first thing squared. It's going to be a plus sign. We're going to leave a space plus the last thing squared. And then the middle is the product of these times 2. So 2py equals x squared. Over here, same thing. It's going to look identical, except because this is a minus sign, it's going to have a minus 2py. So y squared minus 2py plus p squared. And now some nice things are going to cancel, right? So if you look here, we have y squared on both sides, and we have p squared on both sides. Okay, so now I'm going to isolate the x squared, so I'm going to bring the negative 2py to the left by adding it. So let's add 2py to both sides. So this is now 4py equals x squared. And now I want to solve this for y, so I'm going to divide by 4p. There is a 1 up there with the x, so to make this look pretty, I'm going to say y equals 1 over 4p x squared. And this is our generic formula for a parabola, given that the vertex is 0, 0 at the origin. So, more formally, So again, if your vertex is 0, 0, it has this equation, y equals 1 over 4p x squared. If the vertex moves, so say it's hk, right? Well, then you have this formula, right? Because the h and k make it move, you have to use the translation formula, okay? So y minus k, so you slide the k, equals 1 over 4p times x minus h squared. Now, you might know vertex form from your days in Algebra 1 of y equals a x minus h squared plus k. So this is exactly the same formula. All they did was they moved the k over by subtracting it. And the a value here that we typically use is just 1 over 4p. Right? So it's the same formula. Okay. So there we go. So I believe that is all of our background information. Let's just double check. So again, just for emphasis, again, the two formulas you need if the vertex is the origin versus if the vertex is not the origin, right? And again, this variable p represents the distance between the focus and the vertex, or the directrix and the vertex. All right, sweet. So this video was more of the background history of the equation of a parabola. The next video is going to involve 3 practice problems.